Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and we're going to be talking about snowflakes. Whether or not we ever see any in this part of the world is another matter, but if we did, and for the areas that do, I'm going to talk about some of the processes and thresholds that are necessary in order to get snowflakes to form. So let me go on ahead and put myself in the corner here. And we're going to do a little bit of a microphysics review, okay? I know that sounds complicated, but we'll try to make it as simple as possible here. First of all, there's something called the saturation vapor pressure, and you have one value for ice and you have another value for water. And you can sort of think about this as the same thing as the temperature and the dew point, where if the dew point is equal to the temperature, then you're at 100% relative humidity. If it's below the temperature, then depending on how much lower, your relative humidity is going to vary with that. So the saturation vapor pressure is the vapor pressure that needs to be achieved in order for 100% humidity to be achieved, okay? And so the saturation vapor pressure, it turns out, for ice is always lower than the saturation vapor pressure for water. And one of the reasons for that, or the reason for that, is that it takes more energy to go straight from solid to vapor than it does to go from liquid to vapor, okay? Because with liquid to vapor, you're only changing one phase, and with the other, when you go from solid to vapor directly, you're actually skipping the liquid phase and going straight to vapor, and it requires more energy to do that. Okay. Another thing worth noting here is that there are such things as supercooled water droplets that can exist all the way up to about minus 40 degrees Celsius, which, by the way, is also minus 40 degrees Fahrenheit. And so there can be liquid even at very, very cold temperatures. Now, do you remember the pressure gradient force when we talked about the wind, how the air always goes from high pressure to low pressure? Well, because the saturation vapor pressure for ice is lower than it is for water, any supercooled water droplets are going to move toward the ice crystal because of that pressure difference, okay? So the pressure gradient force not only applies to wind, but it applies to the formation and the growth of ice crystals, okay? Now, the difference between the saturation vapor pressure for water and the saturation vapor pressure for ice maximizes in the temperature range of minus 12 degrees C to minus 18 degrees C. And so that temperature range is called the dendritic growth zone. And dendrites are simply snowflakes, the kind of snowflakes, the classic ones that we all know and love. And so water vapor condenses onto those ice crystals, and that is what forms the snowflakes, okay? So you have to get the ice to grow first, and then as it grows, the vapor, the water vapor in the air, the invisible stuff, then condenses onto that ice crystal, and that is what actually forms the snowflake. Now, this is a forecast sounding. This is from the program called BuffKit. And the red line is the temperature and the green line is the dew point. And where the red and green lines touch, you're saturated, and then the farther apart they are, the drier the air is. So what I want to do here is highlight one area here. And this is between minus 12 and minus 18. You see that dotted line here going down to minus 12. There we go, there it is, and then minus 18 here. So that area is shaded in pink. But notice that there's still some distance between the temperature and the dew point. So this temperature range here, the atmosphere is not saturated. Now, I'm going to add in something called the frost point. Because the saturation vapor pressure for ice is lower than water, the frost point is actually higher than the dew point. So you can have air that is unsaturated with respect to water, but saturated with respect to ice, okay? So this blue line here is the frost point, but notice there's still some space between it and the temperature line, so this air in here is not saturated. Now, let's move ahead to a future time. Now, the dew point is getting awfully close to the temperature line, but it still hasn't quite touched it, but the frost point is right on top of it. And so you notice how this pink area here changed to yellow. That means that the air is saturated, that zone is saturated now with respect to ice, okay? And so you've got 100% relative humidity with respect to ice. Now, you can have saturation, but there's one more thing that you need in order to get those snowflakes to form. So this is a time series here, and it doesn't really matter what day or time it is, but what you're looking at here, this area that is outlined in pink, is that minus 12 to minus 18 degrees C range. Where that range is shaded in yellow, that's where that zone is saturated. But then we have to look at a third thing, is there upward motion in that area, okay? And right in here, you see where all these red colors are? This is where we have strong vertical motion, and that intersects that area that is not only in the right temperature range, but also that area is saturated, or that part of the atmosphere is saturated. So if you have the minus 12 to 18 degrees C range, and it's saturated, and you also are getting upward motion, then you've got all those three things coming together right in here, and you would expect there to be heavy snowfall at that particular time. So I hope that makes a little bit of sense. It's quite a complicated process, and of course you've heard the thing about the fact that no two snowflakes are exactly alike. It's really a fascinating thing to delve into as to the different types of snowflakes and the different shapes and the different crystals and all that kind of stuff. It's an amazingly complicated process, but the bottom line for you and I, the snow lovers out there, is that we want the air to be going up in the right part of the atmosphere with the right temperature range and the right amount of moisture, and then we're set. Just doesn't happen that often around here. All right, folks, that is bonus weather video number 1 for this week. Number 2 will be coming up tomorrow. Hope you have a wonderful Tuesday evening, and we'll talk to you again about this time tomorrow. Take care, everybody.